Welcome, folks. Let's talk about this Siemens SKP25. We're going to take it apart and we are going to talk about the operation of it. Funny, not funny story. I've already taken this valve apart. So this is the oil that goes in the valve. It's got a pretty low viscosity. It's kind of like mineral oil. I wonder what it actually is. But I already recorded a video taking this apart and the audio turned out terrible. So instead of uploading that audio, I am re-recording it. But however, I didn't put the oil back in this valve because let me tell you, she was a squirter and I did not take it apart correctly in order to capture all the oil. And this is just what I captured out of it from what I was able to gather that didn't end up all over the Blue Lagoon. So first of all, let me tell you what a Siemens SKP25 is. So this Siemens SKP25 is not to be confused with a Siemens SKP15. So the SKP series has 4 valve types, and 3 and 4 are less often used, but I'm not saying that they're not used. But the most common that you're going to see are the SKP15 and the SKP25. And this SKP25 is what we are talking about. The SKP15, this one right here, is on off in the sense that it opens and closes when it is powered. The SKP25 is proportional and it opens based on downstream pressure. We have a regulator area right here, and that regulator area is modulating the valve open and closed based on the downstream pressure. So we have an electrical terminal box down here. So we have an air port here, and I will talk about that soon, but we have a gas port in the back, and this gets connected downstream of this actuator. Typically, this actuator is going to be installed on a double block. So you're going to have a Siemens SKP15 right here, and you're going to have a double gas valve body on the bottom. And a gas valve body looks kind of like this. This is a single one. But this single one gets installed right down here. And this would be if you wanted to install it on a single valve. For space saving, people typically put it on a double block. This valve body, this stem is spring loaded, and it's always going to be spring loaded into the closed position. So this valve is closed right now. That aside, and this stem right here is going to push down and drive open the valve. And since this is a SKP25 and it modulates, the stem is going to not open all the way and is going to modulate where the downstream gas pressure is maintained so that the gas valve body only has to pass so much gas in order to maintain that downstream gas pressure. And that's going to change with the burner firing rate. So as the burner firing rate goes up, the SKP25 is going to open farther to allow more gas flow in order to maintain the downstream gas pressure. So talking about this air port, so we have a diaphragm here, and we have the gas sensing line here, and this gets connected to your downstream gas line. And then we have the air port here, and this does not get connected to anything. This just maintains open. A lot of times people want to act like this is a vent. It technically could be a vent, but it is just an equalizing line for the diaphragm. And if you put back pressure on this airline right here on this airport, you are going to screw up your downstream gas pressure. And if this were to get plugged, now you're going to end up pressurizing this side of the diaphragm, and the sensing side of the diaphragm is going to get all screwed up and the valve is not going to maintain the proper downstream gas pressure. So unless an inspector absolutely insists, and after you've educated them, that Siemens does not recommend connecting anything to this port, do not connect anything to this port. And I've had some people reach out and say that their inspector says that they need to, and they think it's a vent line. It is not a vent line. It is an equalizing line. It is not meant to be connected and piped out of the building, as that will cause back pressure and screw up the operation of this valve body. And Siemens, right in the manual, says it is not recommended to connect to this port. They do have a snubber fitting right here, which is a vent limiter for mounting into the connection. And they have two of them. One is up to 5 psi and one is up to 20 psi. So if your inspector absolutely says something's got to be put in there, this is the part you want. So this is a used SKP25, and I actually don't have the spring and the insert that goes in here. So you're going to see a brass threaded insert and a spring under that insert. So on a new Siemens SKP25, you're going to have an unpainted spring, which is going to be this right here. And that unpainted spring has a 0 to 8.5 inches of water column set pressure. If you need more downstream gas pressure, you are going to either get a red or yellow, red. So yellow is 6 to 48 inches of water column, and red is 40 to 100 inches of water column. And those springs are stiffer and allow more gas to be passed through the Siemens SKP25 valve body. When you order a new one, unless you specifically order it from Siemens and they install it for you, this comes with the unpainted spring in it. So if you are working on a boiler and you find that the SKP25 is bad, and you remove this one and you install the new one, and then you wonder why you can't get enough gas to your burner, it's because you did not change the spring on your SKP25. Hopefully you still have the old one. And I've seen this situation before at least 5 times. I helped someone over the phone when they couldn't get the boiler to fire after changing the SKP25. I think it was like a 500 horsepower boiler. And they put the new one on. They buried the regulator setting, and they could barely get the low fire setting to work on the boiler. And they didn't have enough gas pressure. So then people think that the new SKP25 is bad. No, you need to go in your old SKP25, unscrew the brass insert, and take out the spring. And it helps to count the turns on the brass insert. So if you're going to take a flathead screwdriver and you're going to put it in there and you're going to count the turns to unscrew it, take the spring out, and then you're going to count the turns when you install it on your new SKP25. You count the turns in, and if anything, you can just do like a half turn or 1 turn less than what you counted. But if you count the turns, then you get a very, very close downstream gas pressure to where you were, and now you're not gassing or lighting off the burner super lean. And that's how you're going to change the SKP25. And that's super important. That's the number one miss, especially for customers who believe that they can just change this out themselves and it's like for like. Well, it's like for like, except for that spring that is in there. And once again, the unpainted spring, unpainted, comes in 0 to 8.5 inches of water column. And if you have a larger boiler that requires more gas pressure, you're either going to have a yellow one or a red spring. All right, so here's the cover. We'll see that right there. So you see that the red indicator is on 0, and it goes all the way to 1 inch. I'm not sure why it's an inch, or like, does the valve actually open just 1 inch on the stem? I'm not sure. But 0 to 1 inch and this red indicator, unless the valve is undersized, is probably not going to get all the way down to 1 inch because this is a modulating valve. So a lot of times people will think that your SKP is not working correctly because when they light off the burner, it only opens to maybe a quarter open. That's because it's maintaining downstream gas pressure. And the stem only needs to barely crack open in order to maintain, say, 10 inches of downstream gas pressure. And then as the burner rate, firing rate increases, the red indicator is going to open farther. Now, a common problem with this SKP25 is people oversize their gas train for the amount of gas pressure that they have. And the SKP25 barely has to open in order to maintain the downstream gas pressure, which can wear out the SKP25 faster because the band and where it's opening, if 0 is all the way closed and high fire is a quarter, so it has to modulate between 0 and a quarter for the full firing rate. And that's a very, very short, narrow band that the SKP is going to be modulating, and it can wear out the valve quicker because it is modulating in that short band, as well as it can struggle to maintain a good downstream gas pressure. Now, these are pretty accurate as far as maintaining a downstream gas pressure, I believe, to the 100th of an inch. Like it's kind of weird for how simple this is and how well it is to maintain a downstream gas pressure. So if you take off the electrical cover, we have line, we have neutral, and we have 4, 5, and 6. So the line and neutral, that's just the same terminal if we would focus. So line, so you're going to connect one wire, your hot to the line. You're going to connect your white wire to your neutral, and that's going to open the valve. And 4, 5, and 6 is going to be your proof of closure. Your proof of closure is a switch inside the valve that makes sure that the valve is actually closed when it's supposed to be closed, and that gets sent back to your burner management system. So that's a switch. And so 4 is going to be the normally open, 5 is going to be the normally closed, and 6 is going to be your common. That is an option. Once again, here's the tag of the model. So we have a Siemens SKP25 and then .011U1. That is the model of or option numbers of the Siemens SKP25. If we go over to the manual, we'll see right here is what I have. So it's 120 volt operating voltage. We have a proof of closure switch, but we do not have the auxiliary switch. If we were to get the 0.012, we would get the auxiliary switch. And I will show you where that auxiliary switch is. The 0.011 SKP25 model is probably the most common one used. The auxiliary switch, that's typically not used on most burners. That can be for it's all up to the burner or gas train manufacturer on what they want to use the auxiliary switch for. But that's typically not a requirement for the burner to work. So let's take apart. And if you didn't already realize this, the Siemens SKP25 is a non-serviceable part. So you're never going to need to be opening it like I am here, and you just change it out. So under the cover, we have 2 green wires going through this block right here, and this is actually a pressure seal that goes to the backside of the valve, and this is going to power the pump. Here we have the proof of closure switch. The proof of closure switch, and I found this interesting, is actually connected to the red indicator. we can see that here. So proof of closure switch connected to the red indicator, and you can hopefully hear that. But as the valve opens, the proof of closure switch arm no longer touches this little micro switch. You can see right there on the micro switch. And then this little screw is how they adjust and set it to set so that when this valve closes, boom, proof of closure switch is closed, and then now the valve is 100% closed. So the proof of closure switch is going to close right before the end travel of the valve. So right now the proof of closure switch is open. Now it's closed. And if we were to order an auxiliary switch, the auxiliary switch would get installed down here under the proof of closure switch. And there is another arm right here. And that arm would go to the auxiliary switch. So the auxiliary switch is just going to be another micro switch that gets installed under this. Not field changeable, so if you need a auxiliary switch, you have to order the correct valve. You can't just add it. So this indicator, which I didn't realize before, super important for that proof of closure. I've never seen the indicator break, but if for some reason you were to break this off when you were screwing around on the inside here, the proof of closure would no longer work. And now you would have to get a new SKP25. Is basically the internals here and how that works. Let's put this back together. Like I said, I've taken this apart already, so I understand and will not make the same mistake that I did last time for taking it apart. First, let's take apart the diaphragm. All right. So what we got is a finger, and this finger is what actually controls the pump and how much fluid bypass happens in order for the SKP to modulate open and close. And this is pretty simple. This is just a housing. This housing is, so this is where the spring would go in and where you would have the brass screw that holds the spring in. So then the spring outputs pressure here, which outputs pressure against this little metal part here. And this diaphragm is going to flex. Then here's the air port, and you can see that the air port, very, very, very small hole, is just an equalizing line. And this diaphragm, then on this side, pushes against this finger switch here and modulates the SKP to open and close. So if you were to push this farther in, the valve would open more. And if you reduce this and push it out, this is spring loaded, the SKP is going to close. So let's actually take the pump out, and I'll note this. So this red actuator has a cable going down through here. The cable goes through these two pulleys, these guides, and gets connected to the bottom here. So when the plunger of the SKP25 goes down, that's what actually drives and pulls the indicator down. The indicator is just spring loaded so that it wants to go back up. I've never seen this cable snap. The cable is pretty resistant, so that's never been a problem for me. But let's take this apart. Got to remove the cable from the ends. All right. And So this is a fluid sealing chamber. So this valve, if you didn't know already, is fluid powered, which I knew, but I didn't know how it actually worked. Let's take this out. All right. Undo the wires. All right. So this is what the inside of the SKP25 looks like. So you can see a wear mark here, and this is a used SKP25. So there is a O-ring inside of this part. So this goes in here like this, if you can visualize that. And you have a chamber up here, and the whole thing is a chamber, but the O-ring is what separates the upper chamber from the lower chamber. And you have a pump, some kind of hydraulic pump here. It's going to pressurize fluid. So there's a sleeve in here. So this sleeve goes here like this, and the whole side of this sleeve is full, and then this part is full of fluid. And that goes in here in the back like this. And when the SKP is powered and this pump is running, the pump is always pumping fluid, and you can see that hole. You can see that hole right there, where that's the inlet of the pump. And that inlet is pumping fluid up through the center here. And this O-ring holds fluid in the top here. And fluid, when the SKP is calling, when this spring, there's a bypass valve, and we're going to get to that. There's a valve on the back of this. There's a bypass valve, and it pumps fluid into here. And fluid is not compressible, so it's going to be able to open the SKP25 and push it down. So as we fill up this chamber up here, it's going to push this section back and push it down. And then when this isn't calling for more gas, the fluid is going to bypass, and it's going to bypass through these ports right here and return to this side of the O-ring. And when it returns this side of the O-ring, the SKP can close. So it's just a simple, very simple hydraulic like ram situation. Pump is always running, and this just modulates back and forth based on the fluid bypass of this valve right here. Let's take this apart. All right, taking that off. Okay, so there'll be fluid up in here. This is a sealing element that you can see. And so we have a spring. We have a spring here, if you can see that. And then we have a little plunger here, and this is going to be your bypass valve. And that plunger, you can see that little dimple right there. See that little black circle dimple? That plunger moves against that, and when this moves, this is going to move back and forth, and fluid is allowed to bypass through this plunger here, and then through this return hole here. And that return hole lines up with this. So this goes in here just like this. And this return hole, the fluid can return. So all we are is we're pressurizing this top portion here on the back side, not this front portion, but we pressurize it. Like I explained, the fluid comes up through here. when this plunger is pushed down, it can't return fluid. So then the SKP is going to open. But when this plunger, or when this finger switch kind of here, when it moves out, which would be for less pressure, when this moves out, this plunger is going to move up and allow fluid bypass. And so once again, this pump is always running. It's always wanting to pump fluid, but now we're allowing fluid bypass. So no pressure is building up in this chamber up here. And now the fluid flows out of here, flows through that hole, which goes through this. You can kind of see how this sits in here, like right about here, and then bypasses to this back chamber. And since you can't build pressure up here, the spring pressure of the valve body that sits right here is going to shove the SKP25 assembly up and back into and closed in the valve body. Now, once we call for downstream gas pressure and we need more of it, this is going to move just slightly, which is going to move this pin, this bypass pin assembly right there. If we can see that, that's not going to allow as much bypass. So then we're going to build pressure in this chamber up here, which is going to push the SKP down and open the valve. So that's how it works. Very simple operation. As always, everything isn't as complicated as it seems at first, but it's a very ingenious operation to be able to maintain very, very accurate downstream gas pressure just by using a little pin bypass valve with a little finger pressure switch. Not something that I would have ever thought of, but that's why I'm not an engineer. But these are a very, very common gas valve actuator, and that is how they work. Put this back together and we can add fluid and see if I can't get this thing to work. I know it's not going to work great because I lost a bunch of fluid, but maybe we have enough fluid in order to get it to work a little bit. Got a flashlight. So you can kind of see down in there. Cooperate. I know it's not in focus. My camera's all messed up. So I'm changing light conditions, but you can kind of see that black ring right at the bottom of the white part. And that's the black ring that is sealing on this part right here. You can see that wear mark right on the white plastic. So we are back together. Let's connect power. And I will push that down to act like a spring, and we'll see if this bad boy still got some chooch in her. So when you are connecting power, you got to be very careful to not break these tabs. And if the tabs are cold or are hot and brittle, you will probably break them. Number one complaint I have with this SKP25 or any of the SKP of the American series is these tabs. The European versions have plugs. I forget what the plug is called, but it's a common plug. This isn't going to work. There we go. It's a common plug, and you wire up the plug, and then you just plug it into the valve instead of doing this wiring mess. The worst is when people use this as a pass-through. So they'll have an SKP15, so they'll only have one set of wires come in. They'll put a small nipple here, and then they'll wire the SKP15. You have to remove the 15 and the 25 off the double valve body, then unscrew them, well, unwire them, and then unscrew them so that you can get that nipple out to replace the SKP15 or the SKP25 or the 15 that's next to it. And then you have to route the wires back through here. This is not a conduit channel. This is, I understand you can do it, but it sucks for the service technicians. So let's see if this works. Hopefully no sparks fly. So we have power. Nope, doesn't work. Don't have enough oil. But you can hear the pump running. This is not something you typically hear in the boiler room, since boiler rooms are noisy. But you can hear that pump running, but I don't have enough oil to make the valve open. But when the spring pushes down, this drives open, and then the spring pressure of the valve body closes it. So that's that. That's SKP25. Hope you enjoyed this video. Hope you learned about it. Always make sure you order the right model number for what you need. These are not serviceable. Always make sure you have the proper spring when you order a new one, unless you specify it to have a different spring. It will have the unpainted spring in it. Please subscribe. Please like the video. Comment if you have any questions in the comment section. If you want boiler training, go to boilearn.com. Thank you.